Hello. In this video, we will be constructing a BST from the sorted linker list, which is sorted in ascending order, like 1, 3, 5, 7, 9. So if this is our sorted uh, linker list, we have to construct a BST. So BST, let's take 5 as a midpoint, 3, 1, and then make 7 and 9, and the output should be like 5 3 7 1 9. So this should be our output for this problem. So what we gonna solve here is so basically we need two classes initially, because we need a definition of tree and definition of linker list, and then we merge it together and come up with BST. We'll construct a BST based on that approach. But the problem is, like, I couldn't come up with a possible solution, so I took some help from internet. So this problem is this solution is not completely my own solution. Okay, so to solve this problem, let's have a class for tree. So we'll make this as tree node. So this tree node will have basically we need value, and then we need left and right paths. So we'll just construct define init. So this will have self and one more value. So we can call this x as the self dot value equal to x, and then we assign left and right self dot left equal to none, self dot so initially, after creating a tree, we just make this into none pointers, and then same like tree, we also need a definition for linker list. So we'll have LL, so which is a short form of linker list that I use. Define in it. So this will also take one value as input, and then we make self dot value equal to x, and then we need a next pointer, self dot next equal to initially it is also going to be none. So now we need to come up, I think I'll write it here. So now we're gonna use these variables and classes. We come up with a solution here. So I would like to write another class. So this one will be called as a solution. So this is a solution part where I wanted to have all the solution part here. So now we need sorted to BST. So we need a BST from a sorted list. So what we're gonna do is, like, we'll write another function sorted to BST. So this will take just self array. So this will take these two just array as a input value. Now we need to get the length. So we need to write a few base clauses here. So I need to return. So if length equal to 0, we just return none. And if length is 1, we'll just return just the first element in the tree node. So if length equal to 1, so what we're gonna do is return, we have to return this value from the tree node. So we just call that tree node, array of 0th element. So we just return this one. So now we need to make the root so these leaves and the main value and the left and right. So for that we just take a variable root equal to, we just call this node class. We're just gonna use node class, and then we make length by 2. So we're just taking a midpointer, so length by 2. So this one is array of length by 2. Okay, so array of length by 2, in this case ours is like 1 2 3 4 5. So this is this is a second, this is the third element. So array, this is list comprehension. So array of second element is 0 1 2. So it will be 0 will be the main root value. So now we need to come up with root dot left. So now we need to make the left path here. So we just say self dot I think I'm just going to use the recursive approach, sorted to BST. So now we just make all the last elements array 0 till length by 2. So this is like left elements which will leave the last elements and will take 1 till the length of this element. In our example this is number 5. So this will be all of our left root dot left values will be assigned to these values. Now we just use get the right thing, right leaves. So this is also similar, self dot sorted to BST. Now instead of having 0 to length by 2, so we just make array till length 2 plus 1. So this is how we till 0. So this one will take care from the midpoint till the end, and then we return root. So we are just constructing a tree. That's it. We'll take another function. So this function is gonna do a sorted list to BST. So this is a sorted array to BST. So this is a sorted list to BST. Sorted list to BST. So this is just, we can write just we'll take empty array, and then we just add the all the elements to this array. So we just take another variable and we'll assign a head pointer. We'll traverse through all the elements. While traversing, we just append all these to array. So array dot append p dot value. Now we just make p equal to p dot next, and then we return this self dot sorted to BST array, self dot the previous function, the first function, sorted to BST. So this one is gonna take array as input. So this is our solution for this problem. This is like really bit confusing in the second part. I try to congest all of them. So this one is like, so if you see here, this is where we are constructing a tree. So we are just taking a root pointer. So root pointer we are getting from the length by 2. So it is odd number. So it is second position in our example. So second is like 0, 1, 2. So this is the root, and then root dot left equal to, we are just calling recursive way. So we are calling the same function in a recursive approach, and we are getting the left leaves and then right leaves, and then we are returning a root function, a root element. And here we are just sorting the list to BST. Yeah, this is the solution that I have for this problem. But this is like one of the really interesting problem that I solved. It took so much time. Thank you.